The next speaker is Gunnar Asplund, speaking about supergrid technologies and cost. As you can see from the biographical sketches you have in your maps, he is an old hand concerning HVDC, working there for his working life, and so the best actually source for the connection of technology and cost.
Thank you, and good morning. First, a little bit, why do we talk about HVDC when we have HVAC, alternating current? And the most of the transmission is done by alternating current. But you can see here on the upper graph, comparing transmission over long distances. The blue line is HVDC, and the dotted red one is AC. That AC has limitations when the distance is longer. And if you come along, above 600 kilometers in a single AC line, it can't basically transmit anything at all. Now there are some tricks to go around this, but this is the intrinsic problem with the AC over long distance transmission. When you look at cables on the lower one, it's even worse, because cable has to be charged 50 cycles or 60 cycles per second. And most of the current, if you have a long cable, is just to feed this capacitive current into the cable, and nothing real can be transmitted. So you can see that a 400 kV AC cable, you can use it up to maybe 20, 30, 40 kilometers. In reality. After that, you have to go to DC cables. You can take next. And then to show where we are with the capacity in the transmissions. You can see this is the voltage and the power on the other axis. And the technology today is to transmit in one single transmission 7,000 megawatt and 800 kilovolts, plus minus 800 kilovolt of voltage with HVDC. This is an enormous amount of power, 7,000 megawatt, that's around 7 nuclear power stations, big ones. This is used in China now. We are building a project like this, 6,400 megawatt, transmitting over 2,000 kilometers. It is the distance from the south of Sweden to the north of Africa. And that we are building now. It's not any future or development. It's happening now, and its total losses in that transmission is around 7%. Then you can see the cables, that's the green ones with the subsea cables. We have a little bit higher capacity, up to 1,600 megawatt, plus minus 500 kilovolt. Land cables, still not there yet, but it's developing very fast. I expect it to come up to the same sizes quite soon. Can take next. These are all projects done with the new technology of HVDC, which is very suitable for building grids. That is the voltage source converter technology. And we have already been working with this since 1997. And we have many projects all around the world. Demonstrating that this technology is now mature. It has had a little bit high losses in the old days. Now the losses are down below 1%. It's close to the same losses as the classical HVDC. And also the power ratings are going up. So we can build 2,400 megawatts transmissions with this technology. This is just a recent example in the offshore. It's off Germany. It's 400 megawatt on a platform out in the North Sea. It's 130 kilometers sea cable, and then 70 kilometers land cable to come to the power station, to the station in the land. And here we can see Europe. This was a quite old thing. We have been thinking about supergrids for many, many years in ABB. And this is from the beginning of the 90s. And this is how to supply all Europe with nothing but green energy. And there you need to have both wind, hydro, and solar. And I think we hit the 300 megawatts, gigawatt of wind. I think this is what European Union now is saying for 2050. So I think we were guessing pretty well. And I think the big bulk power has to be solar probably, because it's more reliable, the constant. And then you have hydro, which is excellent for taking out the variations. But all of this is, of course, completely uninteresting without a very good grid. And this is then this DC grid, and now we have the technology to build these grids also. So we are now going into the development of the things that are lacking there, DC breakers, for instance. And there is also a thing that is very important with the grid that we heard also before, that is standardization, so we don't start to build grid with different voltages, which is then not possible to connect together. And then finally, I would like to show an example of what it costs. That was one of the things that they said. What does it cost? Okay, oh boy, what a question. But I give here an example, what it could look like. This is, of course, not the final grid I showed on the other picture. This is, let's say, a smaller grid, but maybe a little bit more realistic in the shorter term. It's a total distance north-south of 2,000 kilometers, east-west 1,500 kilometers, a mesh size of 300 kilometers. We have 7 sea wind stations and 6 solar and 13 land stations, each of them 2,000 megawatt. And then we have total sea cables, 6,700 kilometers, land overhead lines, 9,000 kilometers, and underground cables on land, 6,800 kilometers. Then I just added it, and as I'm not allowed to give any figures, I just compared it to the cost of generation. Offshore wind and solar. And you can say then that these costs will go down. I think so. But that I think also HVDC will do. So I think it will still be around 25% that you had to add to the generation cost to get the whole grid. That was what I had to say. Thank you.
Gunnar, thank you very much for that presentation and also for the preciseness of the conclusions. And I think that you have given us a great deal to think about.